The p-curve describes the probability distribution of p-values when a study is hypothetically repeated many times. It may be surprising to some that, if the null hypothesis is true, the p-curve follows a uniform distribution. To understand this, we first need to understand the universality of the uniform theorem. This theorem states that the percentile rank of a continuous random variable follows a uniform distribution. The reason for this is that when drawing samples from a continuous random variable, the probability of any two observations having exactly the same score is 0. Consequently, every observation will have a unique percentile rank, and these ranks will be uniformly distributed between 0 and 1. For example, imagine a class of 100 students where everyone receives a different exam score. Each student has a unique rank from 1 to 100. If you randomly select one student, the probability of obtaining any particular rank, such as the 50th rank, is exactly 1%. Given the universality of the uniform, it is easier to understand that, assuming the null hypothesis is true, the p-value is analogous to the percentile rank of the observed sample statistic and therefore follows a uniform distribution. On the other hand, assuming the null hypothesis is false, the p-curve will follow a right-skewed distribution. This occurs because the observed sample statistic is no longer drawn from the sampling distribution defined by the null hypothesis, and thus the p-value no longer corresponds to the percentile ranks of the true underlying sampling distribution. As a result, small p-values become more frequent than large ones, producing a right-skewed p-curve that reflects the increased probability of observing effects that deviate from the null.